a train just shattered 460 kilometers per hour. That's faster than most private jets cruise at low altitude, and it's not a prototype sitting in a lab. It carries real passengers every single day. Meanwhile, in Japan, an experimental magnetic train silently hit 603 kilometers per hour on a test track, a speed that would get you from New York to Los Angeles in under 5 hours. The world's most powerful nations are locked in an arms race, not with weapons, but with trains. Today, we're counting down the 10 strongest high-speed trains ever built. Number 10. KTX Eum, South Korea. South Korea doesn't get nearly enough credit in the high-speed rail conversation, and that's a mistake. The KTX Eum, which entered commercial service in 2021, represents South Korea's first fully domestically designed and manufactured high-speed train. Before the KTX Eum, South Korea relied on technology licensed from French TGV trains and Siemens. Now, they've broken free. The KTX Eum is built by Hyundai Rotem and operates on the Gyeongbu and Honam high-speed lines. Its maximum operating speed sits at 260 kilometers per hour. But don't let that number fool you. This train is about far more than raw speed. It represents South Korea's complete technological independence in rail manufacturing. What makes the KTX Eum significant is its engineering foundation. It draws on research from the HEMU 430X prototype, which hit 421.4 kilometers per hour during test runs in 2013, making South Korea only the fourth country in history, after France, Japan, and China, to develop a high-speed train capable of exceeding 420 kilometers per hour on conventional rail. The KTX Eum is smaller and lighter than its predecessor, the KTX Sancheon, making it easier to deploy on more routes. The train's development cost South Korea years of research and billions in investment. The result is a sleek, efficient machine that has fundamentally transformed domestic travel. Seoul to Busan, a trip that once took 5 hours by car, now takes about 2 hours and 10 minutes. South Korea is not stopping here. The next generation, the KTX Chungrong, entered service in 2024 with a maximum operating speed of 320 kilometers per hour, already placing it among the fastest commercially operating trains in the world. South Korea is quietly becoming one of the most important players in high-speed rail, and the world is starting to notice. Number 9. Renfe AV Class 103, Siemens Velaro E, Spain. Spain operates one of the most extensive high-speed rail networks on Earth, second only to China in total track length. And the crown jewel of that network is the AVE Class 103. Built by Siemens under its Velaro platform and operated by Spain's national rail operator, Renfe. This train is a serious piece of engineering. The Siemens Velaro E, known as the AVE S103 in Spain, entered service in 2007 and set an absolute record during testing, 404 kilometers per hour on the Madrid-Barcelona high-speed line. That made it, at the time, the fastest wheeled train in commercial service under test conditions anywhere in the world. In regular service, the train operates at a maximum of 310 kilometers per hour, though 300 kilometers per hour is typical for most routes. The Madrid to Barcelona route, a distance of about 620 kilometers, takes just 2.5 hours. Before high-speed rail, the same journey took over 9 hours by conventional train. The AAV Class 103 has a power output of 8,800 kilowatts. That's nearly 12,000 horsepower. It carries up to 404 passengers across 17 cars and runs with a distributed traction system, meaning the motors are spread throughout the train rather than concentrated in a locomotive at the front. This makes the train more efficient, reduces wear on the track, and allows for faster acceleration and deceleration. Spain's investment in high-speed rail has been transformative. Air travel on domestic routes has collapsed because trains are simply faster and more convenient for city center to city center travel. The AVE network now connects Madrid to cities like Seville, Valencia, Bilbao, and Malaga, with international connections to France via the Perpignan-Barcelona high-speed line. Number 8. Eurostar E320, Siemens Velaro ST. The Eurostar E320, also known as the Siemens Velaro ST, is the train that connects London to Paris and Brussels through the Channel Tunnel. It replaced the older Class 373 Eurostar trains and entered service in 2015. What makes this train unique is the extraordinary engineering challenge it must meet. Operating safely across 3 different countries, each with different rail systems, electrical voltages, and safety standards, the 320 operates under 4 different electrical supply systems. 25 kV AC overhead in France and Belgium, 15 kV AC overhead in Germany when required, 750 VOR DC third rail in the UK, and 3 kV DC in Belgium for certain sections. It can switch between these systems automatically while traveling at high speed, a remarkable feat of engineering. In France, on the LGV high-speed network, the Eurostar E320 reaches its full operating speed of 320 km per hour. Through the Channel Tunnel itself, speed is limited to 160 km per hour for safety reasons, and in the UK on the high-speed 1 line, it runs at 300 km per hour. The result is a London to Paris journey of just 2 hours and 15 minutes, city centre to city centre. No airport security, no baggage restrictions, no long check-in queues. The train carries 900 passengers across 16 cars and has a power output of 16,000 kilowatts, double that of the Spanish AVE Class 103. It's one of the most powerful passenger trains in regular commercial service in Europe. The E320 has significantly boosted Eurostar's capacity and comfort, featuring wider seats, better Wi-Fi, and improved onboard dining compared to its predecessor. Number 7. ICE 3 Siemens. The L0 D, Germany. Germany's Intercity Express. The IC is one of the most recognizable trains in Europe and one of the most technically sophisticated. The IC3, specifically the Siemens Velaro D variant, designated IC3M in Germany, is the fastest version of the IC fleet, capable of reaching 320 km per hour in commercial operation. The ICE3 entered service in 2000 and revolutionized train travel in Germany. Unlike earlier IC models, which had locomotive-style power cars at the front and rear, the IC3 uses fully distributed traction, motors spread throughout every car. This eliminates dead weight, increases power efficiency, and allows the train to climb steeper gradients, opening up routes through the hilly terrain of southern Germany that would have been impossible for earlier IC models. The train operates on Germany's extensive IC network, connecting major cities like Frankfurt, Munich, Cologne, Berlin, and Hamburg. It also operates internationally, crossing into France where it achieves its full 320 km per hour operating speed on French LGV lines and into the Netherlands, Belgium, and Austria. One of the most important routes served by the ICE3 is the Cologne-Frankfurt high-speed line, which opened in 2002. This line includes gradients of up to 4%, among the steepest for any high-speed rail line in the world, and the ICE3's distributed traction system makes it perfectly suited for this demanding route. Germany's Deutsche Bahn has also ordered the next generation, the IC3 Neo, which entered service in 2022. The IC3 Neo features improved energy efficiency, better passenger comfort, more modern interiors, and enhanced digital connectivity. It represents the continuing evolution of one of Europe's most successful high-speed rail programs. Number 6. TGV Duplex, TGV-M, France. France invented modern high-speed rail as we know it. The TGV, Train à Grande Vitesse, or high-speed train, entered service in 1981 between Paris and Lyon and immediately changed the world's understanding of what rail travel could be. Over 4 decades later, France's TGV still holds the absolute world speed record for a conventional wheeled train on steel rails. On April 3, 2007, a specially modified TGV POS codenamed V150 reached 574.8 km per hour on a 140-kilometer stretch of the LGV Est high-speed line in the Champagne region of France. This record still stands. To put it in perspective, 574.8 km per hour is 357.2 miles per hour. That is faster than a Formula One car's top speed. In everyday commercial service, the TGV Duplex operates at 320 km per hour. The Duplex is a double-deck version of the TGV, designed to carry more passengers without increasing train length. A single TGV Duplex can carry up to 508 passengers, extraordinary capacity for a high-speed train. The double-deck design was a solution to the problem of platform length limits on the French rail network. The TGV network extends far beyond France. TGV train sets operate under different brand names in other countries: Thalys in Belgium and the Netherlands, Eurostar through the Channel Tunnel, TGV Leiria in Switzerland, and AVE in Spain, which uses TGV-derived technology. The French high-speed rail philosophy has been exported to the world. The newest TGV is the TGV-M, also called Avelia Horizon, unveiled in 2021 and manufactured by Alstom. It carries even more passengers, up to 740 in some configurations, and is more energy efficient than its predecessors. It will replace the aging TGV Atlantique and Réseau train sets over the coming years, ensuring France remains a dominant force in high-speed rail for decades to come. Number 5. E5 Series Shinkansen, Japan. Japan didn't just invent the bullet train. Japan perfected it. The Shinkansen network launched in 1964 with the Tokaido Shinkansen connecting Tokyo and Osaka. And in over 60 years of service, there has not been a single passenger fatality due to a train accident. Not one. That safety record is unmatched anywhere in the world. The A5 series, introduced in 2011, is the current frontrunner of Japan's Shinkansen fleet. Built by Hitachi Rail and Kawasaki Heavy Industries, the E5 operates on the Tohoku Shinkansen and Hokkaido Shinkansen lines at a maximum commercial speed of 320 km per hour. On some sections, it operates at 260 km per hour due to track constraints, but its design capability allows for the full 320 km per hour. The E5 is recognizable by its distinctive 15-meter-long nose called the Aerostream design, which is engineered to minimize the sonic boom effect when the train enters tunnels at high speed. Japan has a large number of tunnels on its rail network, and without careful aerodynamic management, the pressure wave created when a train enters a tunnel at high speed causes a loud explosive boom at the tunnel exit. The E5's elongated nose dramatically reduces this effect. The E5 series has a maximum power output of 9,360 kilowatts, operates across 10 cars, and carries up to 731 passengers. Its Grand Class cabin, Japan's equivalent of first class, is considered one of the finest travel experiences available by rail anywhere in the world. Japan continues developing faster Shinkansen variants. The N700S, operating on the Tokaido Shinkansen, reached a test speed of 360 km per hour in 2019. And JR Central is developing the L0 Series Maglev, which we'll discuss in a moment, targeting operational service by 2027. Number 4. CR400 Fuxing, China. China's CR400 Fuxing, which translates to rejuvenation, is China's proudest railway achievement. Unlike the earlier CRH Harmony series, which was built using technology licensed from foreign companies like Alstom, Siemens, and Bombardier, the CR400 Fuxing was designed and manufactured entirely within China by CRRC Corporation. It is the symbol of China's technological self-sufficiency. The CR400 operates at 350 km per hour in commercial service, making it the fastest conventionally wheeled train operating at that speed on a regular timetable. It holds this distinction globally. On the Beijing-Shanghai high-speed line, the Fuxing covers the 1,318 kilometers between China's two largest cities in as little than 4 hours and 18 minutes. For context, the same journey by air takes over 1 hour just for airport procedures, before accounting for the flight itself. China's high-speed rail network, built largely around Fuxing and Harmony trains, now spans over 45,000 kilometers, more than the rest of the world's high-speed rail networks combined. Over 4 billion passenger trips were made on China's high-speed rail network in 2023 alone. These are numbers that are almost impossible to comprehend. The CR400 AFG is an extended version of the Fuxing, with 17 cars instead of the standard 8 or 16, capable of carrying 1,283 passengers in a single train set. The CR400 BF variant was specifically engineered for cold weather operation on lines in northern China and Harbin, where temperatures can drop below -40 degrees Celsius, and the train must still operate reliably at 350 km per hour. China has also tested an upgraded version of the Fuxing at 400 km per hour. with commercial operations at that speed potentially coming in the future as new infrastructure is completed. Number 3. CRH380 AHEXI CR Harmony, China. The CRH380A, part of China's Harmony family of high-speed trains, deserves its own separate mention because it holds a test speed record that most people outside the rail industry don't know about. 486.1 kilometers per hour, achieved during a controlled test run in 2010. That made it briefly the fastest wheeled train ever tested in the world at that time, surpassing even some of the TGV's earlier records. In commercial service, the CRH380A operates at 350 kilometers per hour, the same as the Fuxing, but its extraordinary test performance gives it a higher ceiling. The Harmony series was China's first major leap into truly competitive high-speed rail. It was originally developed using technology platforms from international partners, the CRH380A using Alstom-derived technology, and the CRH380B based on Siemens Valero technology, but Chinese engineers rapidly adapted and improved these platforms. The CRH380A entered service in October 2010 on the Shanghai-Hangzhou and Shanghai-Nanjing high-speed lines. It became the defining symbol of China's bullet train revolution, a revolution that transformed the country. Cities that were previously a full day's travel apart are now connected in under 2 hours. The economic impact has been staggering, with high-speed rail stations catalyzing real estate development, tourism, and business investment in cities along the lines. The Harmony fleet remains one of the largest in the world, with hundreds of train sets operating daily across China's vast network. The CRH380 series represents the moment China stopped being a student of high-speed rail technology and became one of its teachers. Number 2. Shanghai Maglev Transrapid. Here is where things get extraordinary. The Shanghai Maglev, officially the Shanghai Transrapid, is the world's fastest passenger-carrying train currently in commercial operation. It reaches 431 kilometers per hour in regular scheduled service. Nothing else on Earth with passengers aboard moves faster on a scheduled basis. The technology behind the Shanghai Maglev is German. It uses the Transrapid system, developed by a consortium including Siemens and ThyssenKrupp, which Germany ironically never deployed at home due to political opposition and costs. China seized the opportunity, and the Shanghai Maglev opened in December 2002, making it the world's first commercial high-speed maglev line. Maglev, magnetic levitation, works by using powerful electromagnets to lift the train approximately 10 millimeters above the guideway. There is no physical contact between the train and the track, no friction, no steel wheels grinding on steel rails. Because of this, the train can reach speeds that conventional wheeled trains simply cannot achieve, while also providing a dramatically smoother ride. The Shanghai Maglev connects Longyang Road Station to Pudong International Airport, a distance of 30.5 kilometers in just 7 minutes and 20 seconds at maximum speed. By taxi, the same journey takes 45 minutes to over 1 hour depending on traffic. The train reaches 431 kilometers per hour within about 2 minutes of departure. During testing, the Shanghai Transrapid reached a maximum of 460 kilometers per hour, a figure that represents the absolute ceiling of current commercial maglev technology in regular service anywhere in the world. Despite its record-breaking performance, the Shanghai Maglev has not been extended since opening. The cost of maglev infrastructure is extremely high, and China ultimately chose to invest in conventional high-speed rail for its national network, a decision that proved economically wise given the scale of expansion required. But for pure speed, nothing in commercial service today touches it. Number 1. L0 Series Maglev, Japan. Nothing in human history has moved faster on land with a passenger aboard than Japan's L0 Series Maglev. On April 21, 2015, the L0 series set the absolute world speed record for any train, 603 kilometers per hour or 374.7 miles per hour. This happened on the Yamanashi Maglev test line in Japan. At that speed, Tokyo to Osaka, 500 kilometers, would take just 49 minutes. The L0 series is developed by JR Central Japan Railway Company, using superconducting maglev technology. SC Maglev a fundamentally different and more powerful system than the German Transrapid used in Shanghai. While the Shanghai Maglev uses conventional electromagnets that require constant electrical current to maintain levitation, the Japanese SC Maglev uses superconducting coils cooled with liquid helium to near absolute zero, generating magnetic fields of extraordinary strength. The train levitates approximately 100 millimeters above the guideway, 10 times higher than the Transrapid, providing stability at record speeds. The propulsion is also different. Ground-based linear induction motors drive the train forward using a shifting magnetic field, with no moving parts in the propulsion system whatsoever. The only mechanical systems are the landing wheels, which retract once the train reaches the speed at which levitation takes over, approximately 150 kilometers per hour. JR Central has been developing SC Maglev technology since the 1970s. The Yamanashi test line has been operational since 1997, and over decades of testing, the technology has been refined to the point where JR Central is now building a commercial SC Maglev line, the Chuo Shinkansen. This line will connect Tokyo to Nagoya, a distance of 286 kilometers, in just 40 minutes. The current Tokaido Shinkansen takes 95 minutes. The project has faced delays due to construction challenges through the Japanese Alps and a dispute with Shizuoka Prefecture over water table concerns, but JR Central targets opening the Tokyo-Nagoya section by 2034. When it opens, the Chuo Shinkansen will carry the L0 series at a planned commercial operating speed of 505 kilometers per hour. Faster than anything currently in regular passenger service by a margin of 74 kilometers per hour. Japan will reclaim the title of world's fastest commercial train by an enormous margin. The L0 series is not just the fastest train ever built. It is a demonstration of what humanity is capable of when engineering ambition meets decades of patient, methodical refinement. At 603 kilometers per hour, you are moving so fast that the air pressure ahead of the train creates a wall that must be managed with precision aerodynamics. The train must be sealed, pressurized, and the tunnels must be built with carefully calculated cross-sections to prevent pressure waves from damaging infrastructure and passengers. So that's it for today. If you like this video, then please hit the like and subscribe button for more videos. Thanks for watching.